Me again. Now we've got acceleration. So hopefully you've already done your 1.3 notes and you are on to the problems. So here is your equation. Acceleration equals your final velocity, so what you end at, minus your velocity initial, divided by your change in time, or the time interval over which the acceleration took place. So anytime you see that triangle sign, that's just a symbol that means change. So your units for acceleration are a little different than velocity. It's going to be meters per second squared. That squared comes from the fact that you have a meters per second here. You also have a second with your time interval on the bottom. So we already covered that. You at times will also get units of kilometers per hour squared, okay? So obviously if you've got kilometer per hour squared, your time units would be in hours and your velocity would be in kilometers per hour. So just like with the velocity or speed equation, I want to walk you through a couple examples here. So let's say that we have a car that starts at rest. So when I break these down, I always go ahead and I look at, I've got an acceleration, I've got a VF, which would be my final velocity, I've got a VI, which would be my initial velocity, and I have a delta T, that's the time over which the acceleration happens. So a lot of times you'll hear a car starts at rest. If it's starting at rest, it has no initial velocity. So that's an easy 0 meters per second. Now, if the car goes from rest to, let's say, 25 meters per second in a time interval of 5 seconds, what would the acceleration be? So we take our known values, plug them into the equation. So we've got A, which is unknown. Our final velocity is 25 minus 0 divided by 5. So once again, we got meters per second up top, we got seconds on the bottom. I just like to include the parentheses to remind me that I do the math up top first. So 25 divided by 5, your acceleration for this problem would be 5 meters per second squared. Okay? So that's saying that every second, you're going to increase your speed by 5 meters per second. So after 1 second, you'd be going 5 meters per second. 2 seconds, you'd be going 10 meters per second. 3 seconds, you'd be going 15 meters per second. 4 seconds, you'd be going 20 meters per second. And hopefully you get the point, or else just stop, rewind, watch over and over and over again. So that's solving for acceleration. Check. Now we're going to go ahead and solve for velocity final. So let's say that you have a brand new Ski-Doo Summit 850 with the turbo mountain sled, and it accelerates at, I don't know, let's say 8 meters per second squared. Okay, you start at rest. You want to find out, I can't remember if I said we're going to solve for time or velocity final, whatever. Let's go ahead and let's solve for time first, actually. So let's say we want to find out, in order to be going 29 meters per second, how long would you need to hammer that throttle? Okay. So we can go ahead and substitute in. We've got 8 meters per second squared equals final velocity is 29 minus 0 divided by delta T. Okay. So as of right now, all we can really do is clean up the equation. This minus 0, we don't care about it. Right here, the delta T, we got to get it off the bottom. So multiply both sides by delta T. We're going to go ahead and clean this up, rewrite it. So delta T times 8 meters per second squared equals 29 meters per second. So now we can go ahead and get T by itself, divide both sides by 8 meters per second squared. Cancel, cancel. Meters per second cancel. So we're left with just 1 second. So that's going to be our unit, seconds. So 29 divided by 8 is going to give us 3.625. I'm just going to leave that 3.6 seconds. Okay. So that's how long you'd have to go ahead and accelerate in order to hit that speed you want to be going. So that's solving for time. So last one is we're going to go ahead and solve for acceleration. I'll go ahead and get some space here. Let's say that your bike, because everybody can ride a bike. If you're really fast, you can accelerate that at 4.5 meters per second squared. If your velocity final is unknown, your velocity initial is 0. If you go ahead and if you accelerate on your bike for 3 seconds, how fast would you be going? Final velocity. So once again, we substitute in 4.5 meters per second squared equals VF, which you don't know, minus 0, divided by, oh, I almost wrote a delta there instead of a 3. 3 seconds. Okay? So right now, we don't even have to care about that 0 because it's 0. So we can just solve right away for VF. So right now, we're dividing by 3 seconds. So we're going to do the opposite, multiply both sides by 3 seconds. To show you that I can still do math, 5 times 3 is 15. Carry the 1, 12, 13. You would be going 13.5 meters per second. Okay? The second cancels one of them right there. That is what you would be left with. So these are the 3 types of questions that you are going to have to solve for acceleration. Make sure if you have questions, you go back through, watch it again. Don't copy your neighbor because that's not going to help you out when you eventually have your test on it tomorrow. Have a great day.